Okay, last one for tonight, 3.9. This particular problem is pretty straightforward, actually. You've got a spring and a mass. K equals 5,000 newtons per meter. Mass is 10 kilograms. Harmonic force has amplitude. So I'm going to say the amplitude of the force is 250 N. The max amplitude of the mass, the position of the mass, is 0.1 meters. Find omega. Alright, well, the simplest way to do it is just use this function of amplitude. We've got F naught over K over the square root of 1 minus omega over omega n squared. This must be the 10th time I've written this equation tonight. Zeta omega over omega n squared. Zeta equals 0 because there's no damping here. So zeta equals 0. Okay, omega n equals the square root of k over m. It's equal to 22.3. That should be a 2. 36 radians per second. Alright, so this is equal to 0.1 meter. F naught is 250 N. Divide by K, 5,000 newtons per meter. Over the absolute value of a unitless ratio. Well, it would be unitless because these would be the same units, and we're solving for omega, so that works. Alright, so everything cancels out. All that we've got left is the radians per second here. So once we solve for omega, it should come out to be radians per second. Okay. So this is 0.5 coming. Alright, so after some simplification, we can conclude that the absolute value of 1 minus omega over omega n squared, this part needs to be squared still, equals 0.5, just a little. Put this over here, take that over there, and it all makes sense. So it's saying there's two possibilities. A, omega over omega n is less than 1, in which case the absolute value of the thing is moot. So 1 minus omega over omega n squared equals 0.5. Omega over omega n squared, well, omega over omega n equals the square root of 0.5. Omega equals square root of 0.5 times omega natural, or and just plug in numbers again, or this value could be greater than 1. Omega over omega n is greater than 1, so this has become an absolute value, because if this is larger then it's negative, so we turn it negative again and it will give us a positive number. So omega over omega n, excuse me, these numbers should be squared, but considering it doesn't really matter when you square, yeah, it's minus 1 would equal 0.5. Omega over omega n would equal the square root of 1.5. Alright, in the first case, omega would come out to be 15.81 radians per second. And in the second case, omega would equal 27.39 radians per second. And what he put here on the solutions is graphing of amplitude versus the ratio of omega to omega n. And we've got where omega is at resonance, so the amplitude goes to infinity. This should go all the way down to 0. Where is it there? Yeah, down to 0. R value is high enough up, like if it were below, if the amplitude were less than f naught over k, then there would only be one possibility, which would be somewhere along this line, somewhere in here. But since we are at a value that is greater than that, which is determined when zeta equals 0, then you're dividing by a number that is most likely smaller than 1. That is smaller than 1 because the denominator has to be equal to 0.5. So your amplitude is larger than this because your bottom portion is too small. You could have a I don't know, even if your zeta was pretty small, it would still be adding to it. So, well, you can come to this conclusion. This point really is what makes this happen. That's how you know that the line is above f naught over k. Is that function right there. Once you get to that point, then you can conclude that there are two separate values. Alright, equation sheet time again. Of course, this one, which you should have on there about 3 times over now. Not really anything else necessary on here, but you might want to put in something about consideration that this is absolute value, which means it's not necessarily directly equal, it could be the negative.